1, 2, 3, 4. And then here, this is an ugly plate. Yesterday, this was the one that we messed up, and you can see there's that gigantic clearing there. That's not phage. That's just where the top agar refused to go over. And you can see the rest of the plate is just kind of ugly looking. So when you have these gross looking plates, it just makes the experiment a lot harder to read, which is too bad. The phage boxes just don't turn out as well, but we can still use it. Our lambda phage here, it looks like we have a little bit of clearing, unfortunately, so this one was not protected as well. This is MC1061, which that actually makes sense. I've done other experiments that have kind of shown that MC1061 does not get protected. So I see 1, 2, 3 orders of magnitude here, clearing. We don't care about this one. Our veer, so I actually did these spots twice, so 1, 2, I don't see any clearing here. Oh, that's interesting. So our veer was protected, but our regular lambda was not, if I'm reading this right. That's an interesting result. So these two different lambda phages behave very differently in MC1061. And then our T4, I see maybe 2. But again, that's kind of hard to tell. So now we've gone through, we've marked up all of our plates, and we've kind of put numbers to what we're seeing. And so now we're going to go from these plates to Excel. So all I have to do is take a look at these plates, and I've already kind of set up our, what did I set up? I set up our graph thing here, and if we maybe take a close-up of that graph. So I'm deleting that lambda 2. So we have lambda 1, which is going to be there. Then next one we care about is lambda veer, because we're ignoring that lambda 2, lambda veer. And then we have T4, and this is uninduced. And then we have the exact same thing, which is the induced. So lambda, lambda veer, and then T4. And then we have, so that's what's going across this way. And then we have this for our different strains. So DH5 alpha, and then next door we have DH10B, MG1655, and MC1061. So we're just going to go ahead and enter this in. So for this plate, we have no AHL, lambda 1, we have 1E5. And then lambda veer is 1E6. And then T4 is 1E3. Now it's important that before I go any further, I'm just going to note that this is the numbers that I'm putting down are not actual titers. I'm putting in relative titers. So if I wanted to put in actual titers, I would always put them in phage particles per mil. And I would, maybe do a few more calculations for that. So if I was going to do phage particles per mil, what I would be doing is I know the serial dilution that I have, and I just have to say, okay, well I have 1E5, so that's 5 orders of magnitude serial dilution. And this top dilution was 5 microliters out of 100, and that 5 microliters came out of a mil. So I do, this dilution, the times, let's see, 5 out of 100 is 20, times 100, because I put 10 out of that 1,000 into there, and then that would give me phage particles per mil. But for right now, I'm just going to do a relative count, just to get an idea of how these things compare to one another. And again, that would be the difference between doing an experiment for a publication in which you do a bunch of replicates and everything would be really, really tightly controlled versus a quick experiment. This is a quick experiment to get some new information, to just verify a few things, and to get a sense for how these things compare to one another. I really want to know, how do these things compare to one another. I don't need to know the exact number of phage in my LV. And also, that would just take too long to do for this video. But it would definitely be something that we could do if we wanted to. And maybe my boss will let me do that. Okay, so moving on. We have our next plate. So this is our plus condition, as signified by that plus. So for lambda 1, we have 0. For lambda veer, we have 0. And for T4, what do we say? We have 1E3. So 1E3. Okay, and this is going to go pretty quickly. So next plate, DH10B. We're just going to go to the top here. So we have 1E2 for lambda. Then we have 1E5 for lambda veer. Then we have 0 for T4. And then the plus condition, we have 0, 0, and 1E3. So you can see this is going pretty quickly. MG1655 for lambda 1E3. For lambda vir we have 1E6, so really good clearing. And for T4 we have 1E5. And then moving on, we have for lambda 1, this is plus AHL condition, 0. For lambda vir, 0. And for T4, 1E3. Then for MC1061, for lambda we have 1E4. For lambda vir we have 5. For T4 we have 1E4. And then the plus AHL condition, we have 1E3. And for the vir, what do we have for the vir? Oh yeah, we have 0, that was interesting. And then for the T4 we have 1E2. So now we've filled out this entire thing, and we want to change it into a graph. I just highlight. Hopefully everybody knows how to use Excel. If not, it's a pretty good program. I'm just going to go to column, pick a column graph. I'm going to highlight our y-axis here, format axis. I'm going to change it into log scale because everything is orders of magnitude. And then we get this nice graph that's a really good comparison of how our phages are behaving, and then you can change the columns. I'm actually going to, how do I want this? I don't know how I want this. Either way, you can play with the data, but for right now, you can see that you can compare your lambda 1s plus or minus AHL and all these different strains. And you can see you get really good protection on these three, but not so much with MC1061. Lambda vir looks especially good. You can see you get up to 10 to the 5th, 10 to the 6th clearing versus 0 over here. A lot of protection. So we are really interested in using this moving forward. And the T4 didn't work so well. So that's kind of how you would go from these spots to data. And I would do that entire whole process again with the T4 set. I'm not going to do it right now, but hopefully you get the idea. I think that's all I have to say about this. Hopefully that made sense. It's not nearly as tedious as I made it sound right now, but that's basically how you generate data from a plate. So if you have any questions, let me know and I will try to answer them. Thanks for watching.